all of you tonight to Making the Cosmos Local. Can everybody hear me now? Great. Which is the first in a series, Questions That Matter, that we will be bringing to the broader Santa Cruz public. And it gives me great pleasure to launch the series tonight and to have Chancellor George Blumenthal welcome all of you and introduce the event. In addition to being the Chancellor of the University, he's also a professor of astrophysics whose specialty is dark matter, as well as many other things. So he can chime in if he thinks things aren't going well. But Chancellor.
Well, thank you so much, Nathaniel. It's great to be here. And I'm really pleased to see such a full audience and so much interest in the community to the event that we're having tonight. I particularly want to thank the Institute for Humanistic Research for launching this Questions That Matter program. And I think it's really fitting that we're doing this during the 50th anniversary of the UC Santa Cruz campus, because this is our 50th birthday year. And what this group, what this program is doing is bringing humanities work to the attention of our community. And it's so fitting that the Humanities Division is our host for this. Now, it's clear we really do live in a very, very complicated world. We live in a world in which we have to deal with the issues that took place a couple of weeks ago in Paris, or a few weeks before that in Ferguson, which shows that we humans are really challenged by current events and by the need to actually be humans. The level of strife in the world is in some cases extreme. And it really raises questions about what are our prospects for the future. Can we get along? Can we reverse the course of our warming planet? Is there a will to do what we actually are going to have to do as a people? These are questions of the day, and they speak to the work of the humanities. They speak to the work of historians and philosophers and literature experts who actually try to address these issues in the work that they do. And these fields, I want to assure you, are thriving at UC Santa Cruz, where we encourage innovation, we encourage bold thinking, and we encourage people to question the status quo and think about new ways of addressing issues. And the Institute for Humanistic Research is shining a spotlight on all of this good work. Tonight is a continuation of IHR's great work in the community and with the community. And this is being done in partnership with the Museum of Art and History, with the bookshop, with the library, the mayor's office, and with veterans. It's a great program and a set of great programs. Last fall we had the visit of Nobel-winning novelist Toni Morrison, and upcoming there will be a visit by Anita Hill on February 26th. So without further ado, let's get on with the program. Thank you very much.
Thank you, George. So I'm Nathaniel Deutsch, and I will be the moderator of the conversation tonight. I'm a professor of history at the university. I'm the co-director of the Center for Jewish Studies, and I'm also the director of the Institute for Humanities Research at the university. And what we do at the Institute is bring faculty and students together to work on questions in literature, in history, philosophy, languages, the areas that really form the core of a good liberal arts education, and help them to do research, and ideally to bring that research to a broader public like we're doing tonight. Before I introduce the event, I want to thank a few people. First and foremost, I want to thank Irena Polic, who's the Associate Director of the Institute. She's in the front row here. Whose idea it was her idea to have the Questions That Matter series, and really if there's a single person who played the most important role in bringing this event to reality, it was Irena. So I really want to thank you, and I know we're all thankful that you have done such a wonderful job. I also want to thank Courtney Mahaney and Evan Guy, two other staff members of the IHR, as well as the students that work with us. I want to thank Kumba, and I want to thank Bookshop Santa Cruz, as well as a bunch of other people who are either here today or not here today, but played a role in making this happen. So there's really three goals that we have for this event. The first goal is to bring the university to the community and to really demonstrate in a concrete way that UC Santa Cruz, like all the UCs, is your university. It's our university, insofar as we're all residents of the state of California, and we couldn't think of a better way of doing that than to actually literally come down from the hill and have an event here. Secondly, we want to show you what the humanities is up to, the kinds of questions that we're exploring. In many cases, it's the same questions that are going on, as you'll see tonight, in fields like physics and social sciences and the arts, although the perspectives, the methods, the approaches are often different. There is still, even then, some overlap. And lastly, and this has been very interesting for me, because this conversation that we're having tonight is actually not the first conversation that the three of us, Anthony, Minghui, and I, have had about these topics. We've had, over the past year when we decided to do this event, we've had a number of conversations together. So what you're going to be witnessing and hopefully participating in, because at the end of our conversation together on stage, we're going to ask you if you have any questions. And our experts have agreed to take questions. But this is coming in the middle of a conversation that is hopefully ongoing. And I think it's very important that we, in the Humanities division and in the other divisions of the university, cultivate those kinds of conversations with one another and then, of course, with you as well. So I want to introduce our two scholars for tonight and have them come out to the stage. First, we have Anthony Aguirre, and we have Minghui Hu. So we'll sit. And I'm just going to tell you a little bit about who they are, and then we're going to jump into what they think about where we are, why we're here, and so on. So first of all, we have Minghui Hu, who is a professor of history at UC Santa Cruz, whose research focuses on the intellectual history of early modern China, including the role of science in the many encounters and exchanges that took place between Europeans and Chinese in that area. He has advanced training in both the humanities and the physical sciences. His book, China's Transition to Modernity, The Classical Vision of Dai Zen, will be published by the University of Washington Press in 2015. And he was also recently the organizer of an international conference at UC Santa Cruz on cosmopolitanism in China, 1600 to 1950, and will be publishing a book with the same title in the coming year. Anthony Aguirre is a theoretical cosmologist and professor of physics at UCSC, who develops theories of how the universe began and evolved based on fundamental physics and astrophysical data. His specialty in recent years has been the study of a process called cosmological inflation, widely believed to govern the origin and ultra-large-scale structure of the universe. Anthony has studied diverse fundamental physics topics, including Einstein's relativity, the foundations of quantum mechanics, dark matter, and the nature of black holes. In addition, he is the co-founder of both the Foundational Questions Institute, which supports research on questions at the foundations and frontiers of physics and cosmology, and of the Future of Life Institute, a think tank devoted to increasing the probability that life has a future, which is always a good thing. We might hear more about that later. So please, once again, I want to welcome both of them. And Anthony, I'd like to start with a question for you. And in our last conversation when we were having lunch together, you mentioned something that really struck me. It didn't quite make me, cough out my soup or anything, but it was pretty striking. And that was, you said that the Big Bang was really something that happened late in the game. And I had always assumed that was the beginning of everything. So maybe you could talk more about that.
Yeah, so I was trying to be a little provocative, but I stand by that. So what we know, and we as sort of humanity, is that 13.8 billion years ago, the observable universe was this really ultra-hot, ultra-dense sort of fireball of mostly radiation with a little bit of normal particles and dark matter and so on, and it was expanding. And we have a really quite good understanding of what has happened since then, how it's evolved into the universe we see. And that whole picture has really come together in the last sort of 20 years or so during my career as a cosmologist. I played a very small part in that, but it's been really nice to see that come together. So that we know, it's 13.8, not 13.7 or 13.9 billion years ago that happened, for example. But with that success has come kind of indications of what happened earlier than that. And there's a popular idea that the Big Bang, this kind of fireball, was the beginning of the universe. But in fact, what we now have is an idea that prior to that, there had to be another phase where the physics of the cosmos was really quite different. And most cosmologists now believe that this phase called inflation, which you mentioned earlier, was occurring before that fireball stage. And inflation is a phase where the universe isn't just kind of expanding, but it's being forced apart. There's a kind of anti-gravity inflationary force pushing it apart. And that dynamics, that force pushing it apart, gives the universe the sort of structure that it needs to have in order to evolve into what we see now. Now, what's really fascinating about that inflationary phase is it could have just happened for a tiny, tiny fraction of a second, and before that was kind of the beginning of the universe. But what people have realized over the years is that inflationary phase also could have gone on for a long time, or a super long time, or kind of indefinitely, or forever. I mean, the universe could have always been inflating, and then at some point, in some region, stopped to create the fireball that evolved into our universe.
So there still was a Big Bang.
There was a Big Bang, but the Big Bang, rather than being the start of the universe as a whole, was really a transition that kind of created our observable universe as we see it. It created this fireball that evolved into everything that we see. But there was lots of other stuff before that and lots of other stuff elsewhere in this picture.
So Minghui, turning to the case of China, what are some of actually this is technically cosmogony, where the universe comes from, which is of course a part of cosmology. What are some of the cosmogonic theories that were popular in China, pre-modern China, let's say?
Well, in 1914, a very cold night at Beijing, but that was not when the cosmos began. The president of the New Republic of China went to the altar of heaven to perform an age-old ritual to pay the respect to the heaven. But he was the president, he was not an emperor, because China's last empire unceremoniously ended in 1911. So he was a new president, only 3 years old into a new republic. And he was performing a ritual the emperor should have been doing. And he wanted to be the emperor. That was the source of his political power. And the next year, in 1915, he declared himself to be the emperor. And the entire republic just fell apart. The story, of course, was not about China's new republic, was not about China's politics. It was about how he had to pay his respect to heaven. And the word heaven in Chinese, Tian also means the cosmos, which was the origin, the very origin. About 4,000 years ago in Chinese history, that's when they first conceptualized the idea of the cosmos. But that was the moment in 1914, that was the moment when the American ambassador, Paul Reich, who was there, invited to watch that ritual. He was educated in the University of Wisconsin, medicine, and he was a political scientist, and he was the ambassador in China, and he wrote a book about Parliament in China. And I suspect that was the moment that entire Chinese cosmology was first introduced to North America. Of course, as we heard before, that the old European sinology and many, many other issues, many European missionaries had been to China, had been in contact with Chinese cosmology, but those things were not popular in North America. It was really his effort. He took a lot of photos, introduced the Chinese cosmology into North America.
But what was the basis of the cosmology? I mean, where does Anthony was describing this process of inflation and then a Big Bang that occurs. what were some of the views in China about where the cosmos comes from? I mean, it was used in this way for political purposes, let's say, but what were some of the popular views of?
Yeah, I like to say that the cosmos was not unique or particular in China. I like to make a distinction between the pre-modern cosmos or the cosmos in most pre-industrial societies. In that sense, they share very similar view of the cosmos. Like, for instance, the sky is round. It may look like an egg. It covers the earth. That sort of things were fairly common in different pre-industrial societies. And I would say that the Chinese was particularly interested in the cosmos because they view the cosmos as a source of human pattern, political power, and therefore, in that sense, the Chinese had kept very good records of watching sky uninterruptedly for almost 2,000 years. So in that sense, that was pretty unique.
Okay. So the word cosmos it's a Greek word. It means order. And this is actually a question for both of you. You've already indicated some ways in which the political order was connected to the cosmic order. But in ancient Greece, it was contrasted with chaos. And I wonder, do you think that cosmos, the notion of order, is still useful in terms of contemporary cosmology? Is it the term that we should use to define what's going on? And does chaos have a place in the kind of cosmology that you work on?
I would say yes to both. I mean, I think there's one of the things that's been pretty shocking, I would say, over the sort of development of this Big Bang theory is how, and I don't mean to denigrate the efforts of my colleagues, but how easy it's been, in a sense. To figure out 14 billion years of cosmic evolution and, in mathematical detail how dark matter agglomerated and galaxies formed and stars form and sort of get theoretical predictions that match a whole range of observations and kind of get it right. I mean, we can't do that with the weather, right? We're much better at predicting where galaxies are and how they form than how clouds form. So there's an amazing level of simplicity to the universe and order to it that has allowed us to be so successful in sort of understanding the large scale picture.
So that's the cosmos part of it.
So that's the cosmos part of it. There certainly is lots of chaos and randomness. I mean, as just one example, when you look at the Hubble Deep Field picture or other astronomical things that show you where the galaxies are not sort of uniformly distributed through the universe. They're in patterns. They're kind of these sheets and big empty areas where there are very few galaxies. There's a whole pattern to it. And one of the programs of cosmology was to understand how that pattern arises. And what we've now worked out is that it arose from really, really tiny variations in the density of the universe in that sort of fireball epoch. So variations of about a part in 100,000, gravity amplified those to the point where the parts that were a little bit less dense were now empty voids between galaxies, and the parts were more dense, there were lots of galaxies. And then people wondered, well, where did those initial variations come from? And the current theory, which is again involved with this inflation theory I was talking about, is that they came essentially as almost pure randomness. So quantum mechanics, which many people will have heard of as this kind of weird physics theory, one of the fundamental tenets of it is that things are not deterministically predictable, that if there's some physical process, there will be a sort of irremovable random element to it. And that element was there in the early universe. And so in some sense, quantum mechanics forbade the universe from being totally uniform. It had to have these little variations that happen completely at random. So the fact that the Milky Way galaxy is here rather than somewhere else, so that there's, we're here rather than empty intergalactic space, is really some tiny little quantum process that happened 14 billion years ago. And there's just a tiny little bit more density in this little bit, like literally that small, from quantum mechanics. So it was a roll of the dice that our galaxy exists. And so, there's this randomness really suffusing the whole universe in terms of how it actually played out in detail.
Now, in the case of the material that you look at, it sounds like the cosmos, the physical cosmos, was part of a broader order of politics, institutions, all sorts of things that were connected to one another, connected ritually often. Where would chaos fit into that? Would there be a big push against that because it would not only destabilize notions of what the world is, but also political authority, for example? Or was it worked into the system somehow?
Of course, they were intimately connected throughout history. It was not the physical sky that actually was in chaos, right? It was how humans, especially in my research, in my case, it would be how Chinese observe and interpret all the signs in the sky and how they consider that as part of the prediction of the pattern of a human society or how human society will be interrupted or changed. And therefore, and this is not just Chinese case, by the way, and the Chinese sense of the conception of the universe was quickly shared by their neighbor regions. The most prominent example would be like in Japan or in Vietnam. And we know from archaeoastronomy that many pre-industrial ancient societies in America also share a similar notion of the connection and patterns.
Did they have a sense of randomness that might be going on in addition to the order that they...
Of course. And that sort of a randomness could be brought back to the balance if the humans only willing to follow the pattern and the cosmic guidance.
I see. So humans had to intervene in order to bring back order.
That's right.
I see.
And it's cyclical in the sense that it repeats itself.
Mm-hmm. So this actually, I think, is connected to another question I had for you, Anthony, which is, does it matter how the cosmos began? In other words, is cosmology about why or only how the cosmos came into existence? I mean, in the case of what Minghui is talking about, people connect. I mean, it is connected to social institutions and to health and so on, and people can play a role in actually potentially manipulating, it sounds like, through rituals and connecting to it. But in your case, is it just something that you kind of think about abstractly, or just theorizing? And do you and your colleagues ever talk about why this stuff is important, or is it just, as you pointed out, figuring out okay, we know it's not 13.7, we know it's 13.8, and
yeah,
or is that forbidden?
No, there are a few things that are forbidden behind closed doors. No, it's an interesting question. I think when there's a tendency with the beginning of the universe to imbue it with a sort of mystery, both from a kind of religious standpoint where people think that's when something supernatural happened, or from a scientific standpoint of that's where quantum gravity is. It's almost the same feeling that there's this mystery that we don't understand, and if we just understood that, then everything would kind of make more sense. And I'm not entirely convinced of that, in that if you consider, for example, the cosmology that I've been talking about with inflation and so on, if you compute how much matter there actually was at the beginning of the universe, that our whole observable universe, it grew out of something that was about 10 kilograms, right? So it was fantastically dense and all kinds of interesting stuff was going on, but it's just 10 kilograms. So how crucial is it really how that 10 kilograms got there? Will it really have a huge...
I guess it depends on...
So it's an interesting question, but I think in some sense the more interesting one is the whole development since then, both in terms of how that whole thing unfolded through history physically, but also where if you're talking about the origin of all things, there aren't just particles in the universe, and there aren't even just stars in the universe. There are things like chairs, and the origin of chairs. Chairs exist only because people made them. People exist only through this incredibly complicated evolution of life and human life and society and ideas and technology and so on, all of which are kind of, at some level, just as important creation processes as the creation of galaxies and the creation of planets. So I think, to me, it's not clear to me that, although I'm a cosmologist and I love studying the origin of the universe, I think at some level we shouldn't discount the importance of this kind of steady creation of new levels of interesting complexity and meaning that we, through our history and through our actions, have brought into being. So at some level, I feel like that's where the meaning is. That's where the why is, more than at the very beginning. My personal view.
Yeah, in this evolution of the cosmos, you're talking about the cosmos evolves a very, very long time scale, right? But would you say that any humans on this planet about 5,000 years ago were watching the same cosmos we are watching now? Would 5,000 years matter in the evolution of the cosmos? Or if the cosmos changed just a little bit, it doesn't really matter about their observation and our observation?
Well, I think in terms of, if you look at the actual, time scales over which things change astrophysically or cosmologically, no, $5,000 is all, 5,000 years.
That's a very good slip, by the way.
I don't know where that came from. Is almost nothing. It's getting worse and worse.
You want some water?
So 5,000 years is almost nothing in terms of the time scales. I think the question of whether they saw the same cosmos, almost certainly not, because they were completely different, right? Because we look at it through a set of eyes that are completely different in terms of how we, when we look up and see stars, we have a completely different conception. I certainly have a different conception as an astronomer and a cosmologist than anyone did 5,000 years ago. And so I think the real progress is the internal one, is in our side of the perception of cosmology rather than the sort of side on the stars. It's really us that's really changing over that period.
And historically, one of the things that you study is the way in which Chinese and Europeans, for example, Jesuits, who come to China, exchange ideas about, among other things, the cosmos. So could you talk about the impact of that encounter with the West in the form of Jesuits and others on Chinese ideas of cosmology?
Yeah.
I mean, how do they look at it differently before and after, for example?
Of course. And it's very, very interesting that you brought that up, that we actually are looking at in drastically different cosmos. But a lot of historians just assume that's the physical reality, that's the same sky we're watching, that's the objective realities. And therefore, what Europeans saw maybe 500 years ago would be exactly the same physical external reality like the Chinese saw about 400 years ago. Okay, that's generally the assumption. But what European missionaries brought to China in the 17th century changed almost everything in how Chinese conceptualize the universe. When I say everything, I mean how they picture the shape of the cosmos, but not how they conceive the nature of the cosmos, which means this, and we're going to bring up the Chinese word that probably many of you heard of, is the qi. It's a fundamental component for the Chinese cosmology to consider as the fundamental nature of the material forces of the universe. But the shape of the universe does not really matter to Chinese. Whether or not the Earth is the center or the sun is the center, it doesn't matter.
How about whether it's flat or is
Yeah, whether it's flat, it matters sometimes, but we can work around that too.
But was it thought that it was flat or not?
Yeah, well, at first you saw it, well, in ancient Chinese texts, they thought that the earth was square and flat. And that square was the key word in the ancient scripture. But when Jesuits says, it's really not square, we have proof, we have map, we have, we sail 2,000 miles to this place, we have proof that this is not square. Chinese bought it. Not a problem. So the shape of Earth was never really a question or a challenge. Here's the key part. It never challenged the fundamental cosmology in China. In fact, the Chinese accepted the entire cosmography, which means the shape, the cosmos, without much questioning or resistance. And that cosmography continued in China until 20th century, until the modern science was introduced again, and they changed everything.
Now, Anthony, do you think that there's anything culturally specific about the cosmology that you and your colleagues do?
It's interesting. One thing that I've noticed I'm thinking about this view where the universe, in a sense, began 13.8 billion years ago, but in another sense, maybe has always been there and is eternal. And historically, the Big Bang theory had a rival, the steady state theory, which was also a vision where the universe was eternal and was always there in more or less the same form. And as far as you go back, there's kind of these two modes of thinking, this finite universe and kind of often a very young one, and then this very eternal and complicated and messy and big universe. And as I have sort of looked through the development of cosmology, you can see that people really are attracted to one or the other of these things and kind of cling to one view as making sense and trying to explain the other one away. So, for example, one of my favorite thought experiments in astronomy is if you go outside, you'll see that the sky is dark. Right? This is a very basic observation. But it turns out to be actually rather hard to explain because if you conceive of the universe as being sort of infinite and static and just kind of filled with stars, then it was noticed quite a while ago that the sky should actually be blazing with light because every direction you look, you're kind of looking right at the surface of a star. If the universe is infinite, you might have to look really, really far, but eventually your sight line will hit the surface of a star. So the sky should be blazing as bright as the sun. This is called Olber's paradox. And this was realized in sort of the late 18th century, and they tried so many ways to explain this away. Like they had this idea that the uniform, eternal universe, this is a particular set of people, sort of the astronomers and physicists at the time, they tried so many different ways to explain this away, and none of them, except an interesting exception of Edgar Allan Poe, came up with the idea that the universe was just finite in age, right? So it was so enculturated in them. Einstein, when he developed general relativity, the first thing he did was create a static, eternal universe model. It made no sense. It's so embarrassing that Einstein came up with this model. I mean, he's so brilliant, but you can't figure out how he didn't see the 12 different flaws that this model had. But he had a very deeply rooted conception that the universe should be eternal. Similarly, in the work that I've been thinking about with eternal inflation, sort of bringing back the eternal picture, huge resistance because cosmologists all nowadays think of the universe as starting 14 billion years ago and can't get it out of their head that maybe there's a different picture. So we keep kind of swinging back and forth where there's a community that adopts one picture and is very, very reluctant to let it go. So I'm not sure exactly where, the cultural input into that picture and sort of what feeds that sort of philosophical prejudice towards one or the other is hard to pin down, but it's certainly there.
I mean, do people ever say in meetings that you have, like, I've been reading this Hindu text, and or anything like that,
Never.
No.
But they might be reading the Hindu text.
You're right, but they won't say it.
They won't say it.
So the language is primarily mathematical. I mean, what is the language in a broad sense of what you work in and how you express these
So the language is fundamental physics. It's mathematics. It's a little bit sort of semi-philosophical in the sense that you might say, that sort of conception doesn't make sense for this reason or that reason. That turns out not to work so well. As an aside, one of the most fun things when I was a grad student, my advisor introduced me to this. In Kant's Critique of Pure Reason, there's a kind of appendix called the Antinomies of Pure Reason, where he proves both that the universe is finite and that it's infinite. Like ironclad proofs. He proves also that the universe is finite age and that it's eternal. So he really convincingly proves all these things. And it's fascinating to see both sort of how convincing they are, but also how they've been sort of undermined by new physical ways of thinking. So once you understand Einstein's general relativity, for example, the argument that he gives for why the universe has to be infinite, doesn't make any sense. So he says the universe has to be infinite because if it was finite, you'd go to its edge and kind of crack down the wall and look through, and what else is there but other universe, right? So you can't have a boundary to the universe, so it has to be finite. But Einstein showed us that gravity can curve space-time, and you can have a space-time that is like the surface of a sphere, where there's no boundary, but it's still finite, like the surface of the Earth. You won't ever come to the edge of the Earth, right? But it's still finite, and the universe can be just the same way. So I think what physicists, there's this interesting interplay where there's a necessary kind of philosophical component to it, in that you have to have a worldview and you have to have a sort of viewpoint, but it has to take a second seat to the mathematics and the physics, because you quickly find that if you don't understand the mathematics and the physics, you just aren't going to get things right, and you're going to make all kinds of assumptions about what's possible and not possible that don't necessarily hold.
Mm-hmm. And in the case of China, what was the language? I mean, that was used. Was it a particular to express cosmology? Was it religious language? Was it mathematics? Was it?
It was both.
It was both.
And obviously, there was no modern equivalent of words like infinite or eternal. In fact, this scholar in the 17th century China I study, he was not recorded in any history books because he was too normal. In history books, we only record crazy people or very exceptional figures. And one of his quotes I love most, because he represents millions of literati scholars in the 17th century. And he basically says, the cosmos neither begins nor ends. The cosmos is so immense that it can encompass almost every living thing in it. That's sort of a language, and it was couched and phrased in Confucian terms, not the Buddhist terms, not the European Christian terms. At that time, all these guys, they had been fighting Buddhists for their lives, or at least they pretend to fight Buddhism in their lives. But they were critically aware of the Christian cosmos that was brought to their seashore. They were dealing with it.
And did he come up with this phrase in concert with what was going on with the Europeans that he encountered, or was this an internal Chinese development? This notion of the cosmos not having a beginning or an end.
They were actively battling the idea that cosmos has an origin. And that was very much a Christian idea for the Chinese. And the strategy the Chinese use is like, you guys are just like Buddhists. The Buddhists thought the cosmos has an origin. So you guys are just like evil Buddhists. So they lump them together as a way of invading their own cosmology.
And what happens when, in the 20th century, either through nationalism or even later with the communist revolution, what happens to Chinese cosmology then?
Of course, China didn't really, there was a lot of internal contradiction. For example, a civil war in China, 20 million people perished. So in terms of Chinese history, changed a lot. But in terms of their development, their understanding of nature, it didn't have leaps and bounds, but the West did. So what happened was that the first encounter with the West through the European missionaries, the Chinese scholars did not feel like they were so far behind. In fact, they were dealing with it just fine. But the second encounter in the 19th century was a totally different ballgame. So that was when science came with imperialism, hitting the seashore of China, and everything changed. And ever since then, I would say 1860 was the line that crossed. Ever since 1860s, almost all East Asians, well, South Asians as well, probably the rest of the world, have to deal with the idea of the Western superiority and scientific superiority. That was when they had to learn, and everybody was forced to learn how cosmos was conceived in scientific terms.
And so now in contemporary China, for example, the cosmologists, I mean, maybe you have colleagues also in China, I mean, would they be working with the same models, and is there any remnant of the traditional Chinese cosmological views, or and this is for both of you, would you say that the curriculum, the theories, it's a kind of globalized, universal form of cosmology?
From what I can tell, I would say so, yeah. It's a pretty international. It would be very hard, I think, looking at a cosmology paper that comes out, in a journal nowadays, to draw any real connection to the sort of cultural background or historical background of the authors. I feel like you really couldn't tell. It'd be interesting to try, but I think that would be very hard. So I think it's kind of converged in that sense. One of the questions I had for you, I've always been curious about it. The Chinese civilization was so much more advanced than the Western one for so long, and yet Western civilization sort of devised science and with it technology and the whole Western intellectual tradition. Do you have your own theory or sort of feeling for why that happened? Could it just have, was it random? Could it just have easily has happened in China, or were there were elements to Western culture that kind of didn't exist in China that led to that process happening?
A British chemist and historian, his name is Joseph Needham, he compiled these volumes and volumes of books documenting all the achievements, discoveries of nature and mathematical achievements in China up to 17th century. He called these volumes Science and Civilizations in China. Not many people pay attention to the title, but what I think the most important part in the title is science is separated from civilizations in his view. And he's very clear about that. And his most interesting image is that modern science occurred in the West, of course, historical fact. No need to deny that. But why did modern science occur in the West was that so many important achievements outside of the West eventually flew and contributed to the rise. He was thinking about Arabic civilizations and Chinese civilizations. So, and they eventually flew to the West and culminated in modern science. So he likes to use the metaphor of the modern science as an ocean, all right? All these little things, achievements, stuff, just like rivers, flow into the ocean. And modern science is that combination. And that, in his view, should be separated from the civilizations. We should not think about science is owned or occurred only in a specific civilization. What he's trying to say is that science is not civilizational. It should be separated. And we should think about science as a process contributed by many civilizations. I like that.
So we've got a few more minutes, and I want to kind of move us. We've talked about beginnings, sort of middle, and now I'd like to move the conversation more towards the end. Not only the end of the conversation, but also the end of the cosmos. And I want to bring up something that was actually in the newspaper recently, which is something called Fermis paradox. Mm-hmm. And the article connected it to certain developments in global warming. And so maybe you could explain what Fermi's paradox is, what it has to do potentially with global warming and potentially with the end of this and other worlds.
Yeah. So I guess the way I'd say it, I feel pretty confident that if humanity lasts another, say, 500 or 1,000 years without self-destructing, that we'll go out into other planets, we'll colonize even other star systems. The distances are incredibly immense, but once we leave the planet and sort of start expanding, we're a very expansionist species. We like to move into new territories, and the universe is a big place. So if you ask yourself kind of how long would it take for us to spread throughout the galaxy is immense. It's 100,000 light years or so across. But even if you just travel at a tenth of the speed of light, that's only 1 million years that it would take for us to sort of spread throughout the galaxy. And that feels like a really long time, but the galaxy is of order 10 billion years old. So you have to ask yourself, if the galaxy is 10 billion years old, if there were lots of other civilizations out there, like ours, that can have technology and like to expand, you would think that many of them would have taken over the galaxy by now, right? And there's no sign of that. Maybe some of them are, just not expansionist or hidden away or whatever. But it seems almost certain that if there were lots of civilizations, one of them would be moving stars around into cool patterns and stuff, and the galaxy would look like a very different place. So Fermi's paradox is sort of, given that it doesn't take long to colonize the galaxy compared to the age of the galaxy, where are all the other civilizations? And if you accept that there aren't such, other such civilizations in the galaxy, then you're forced to say, okay, we know astronomically that there are at least tens of millions, probably billions now, of Earth-like planets in possibly habitable regions. That's kind of what the new science of finding planets.
Or?
Yeah, so planets that are sort of the right distance from their stars to have liquid water and things like that. We can't see them at this point, but we can kind of statistically figure out how many there should be there. So if there are, say, billions of planets that could have life, what happens between the planet and the rocket stage, or the solar system civilization stage? And there are a couple of possibilities. One is that there's something that's really hard sort of before you get to technological civilization like ours. It could be that life is incredibly rare for it to arise, or it could be that it arises all over the place, but it's all just bacteria. You never get multicellular life forms. Less plausibly to me, it could be that you can get that animals arise all over the place, but hardly any of them get that smart, or that they get smart and they don't have technology. Those seem hard for me to buy. Mm-hmm. So I think we have to really hope for that, because the alternative is that there are lots of civilizations that reach a technological stage, but none of them make it out into the universe and kind of take over the galaxy. And that's a scary thought, because that's right where we are right now, right? We're at the point of deciding as a species, are we going to sort of survive for another few hundred years, build rockets and colonize Mars and eventually go to Alpha Centauri and so on, or are we more or less going to self-destruct? And if you believe that we're the only potential civilization in the galaxy right now, maybe even in the observable universe, it's not a crazy thing if you think about the numbers. The stakes are incredibly high, right? We might be the sort of chance of the whole universe to fill with life, and we're going to blow it in the next 100 years. I mean, that is really alarming. And yet, although the stakes are incredibly high, we're just rolling the dice over and over again. It's like we're sort of pulling the perverse slot machine where, 90% of the time it gives you a couple bucks, but 10% of the time it kills you and your whole family, right? And couple bucks, all right. So I think one of the things that's been just sinking in more and more to me as I think about our place sort of in relation to the universe as a whole is how incredibly high those stakes are, and how even if you can increase the odds by 0.001% that we're going to make it through that bottleneck, that's hugely important. You've changed, you've kind of really altered the future possible trajectory of life in the universe. And so I suspect that at some level, there are many times where people thought like this is the important time, like the world's going to end tomorrow and everything's going to change. But I feel like we really are there now.
On that note.
And I think one of the things that's sort of contemplating our relation to our place in the galaxy and the universe and so on is seeing how big the stakes are and seeing that we have to take that long view if we're not going to really do something that the whole universe is going to regret.
Minghui, do you have a solution?
It's a tough act to follow.
What are some of the views of the end in traditional Chinese sources?
Well, basically in China today, as Anthony suggests, most of the scientific curriculum is the same as the West. They consume more literatures with incredible amount of eagerness to catch up with the West. And this has been going on for at least 150 years old. And the Chinese elite have been coping with this anxiety to deal with the superiority of the West. And they believe science is the key, is how they catch on or catch up. Except Chinese medicine. So the cosmos, the traditional Chinese cosmos is completely gone, all right? Completely gone. It was gone in the 1920s. It was completely gone in the 1960s during the Cultural Revolution. But the Chinese medicine, which is very peculiar thing, survived as a national project in China, which embody a lot of cosmological principles in their medical concepts. And that survived alone as a national project in China.
All right. Well, thank you, both of you. That was wonderful. And now that you have the opportunity to ask questions. And we have a couple of students. We have 2 microphones that are going to be going up and down the aisles. So would somebody like to start with a question? 1 per person, please. Anyone want to start? Yes, over here.
Hi. So the question I was going to ask is something that Anthony said earlier. He said if who we are and what we are started as 10 kilograms, what would be the counterpoint? What would you say is the 10 kilograms of the Chinese society?
How much chi would fit into 10? That's another way of phrasing it.
Cannot be measured.
Cannot be measured.
Or observed.
Or observed. But perceived.
Or perceived, probably.
Yeah.
Yeah, because that's basically how this, popular perception of martial arts is about. It's about perceiving how qi moves in your body and how you can manipulate the qi in your body. And that itself was a cosmological concept, but survived today in popular culture and in Chinese medicine.
I don't know if that answered your question. Do you want to rephrase it?
So I guess it's more from the point of view of not necessarily, what is the origin of a Chinese culture. I mean, we've already said that the origin of all this is something that it's very, very complicated. What would you say is some culminating thing that you could trace back to the origins of the thought, the thing that gives the people the ability to move forward as a culture, the ability to integrate something that is brought to them from the West, the ability to strive, to emulate, understand, and move forward, something that gives them that basis, something that they can derive who they are, what they are, and how to move forward from.
Okay. So it's a bit.
I don't know. Well, I was told that historians are obsessed by origins. I don't know about cosmologists.
Guilty.
Okay. All right. Well, maybe you can think about it. Another question. Yes. We have someone back there.
Hi. So, Anthony, you said at the end there are two options for the future of humanity, that we colonize other galaxies or we self-destruct. And I think a lot of us are interested in climate change and our destruction of our planet. Are those the only two options? Is there a third option of preservation or not?
Oh, yeah, well, certainly I think, there's an option of just kind of building a sustainable culture here on Earth that lasts, thousands or millions of years. I just don't see it as realistic. I think if we survive, the next few hundred years and kind of don't fall into one of like 30 different pitfalls that are in front of us, I just think it's very likely that given the level of technology we would enjoy in 500 or 1,000 years, that we're going to go out and explore the rest of the universe. So I don't think that's necessarily, I'm not advocating it so much as saying I think one of those two things is just likely to happen. I could also imagine that we'll not totally self-destruct, but just kind of our civilization will fall into chaos and it'll build up again and fall into chaos and we'll just never quite get off the planet. I could see that happening for quite a while. But again, I think there's only going to be so many cycles before we either succeed or really eradicate humans. So yeah, I'll stand by those two basic options in that sense.
Yes, sir.
Very.
We have. Maybe we have this one first, and then you can ask it. Thank you.
I like to go to the beginning of your talk about the Big Bang. And the question really has to do also with the historical point of view. We had 1,500 years of early history of cosmology, Greek and Arabs, which very successfully explained the observations, but it lacked the physics, as you know. And it wasn't until the 17th, 18th century that the proper physics was developed to understand simply planetary cosmology. Then we had to wait until really Albert Einstein before we could go further and understand the physics of the early universe up to the Big Bang. Now, the question that I like to pose to you is that cosmologists want to study now the physics before the Big Bang. That's what you told us earlier. But the problem is that they also agree that you have to unify gravity with quantum mechanics. And that has escaped our ability. No one knows how to do it. So from a historical point of view, if in 100 years or so we finally achieve that, will the people who understand the physics laugh at the feeble attempts to understand early cosmology without the physics? I mean, that's what history has taught us. Right?
Yeah. Well, I completely.
Therefore, how do you explain all this enormous amount of efforts that are being put into speculations where the physics is not there?
Yeah, so I completely agree with you, but I think we have to be careful about what exactly we're talking about. I think Big Bang has gotten to be a confusing word because it refers to a few different things. One is the Big Bang theory, that the universe is expanding and evolving and so on, has a Friedman-Robertson-Walker metric and blah, 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 blah. That's just true. There's the Big Bang fireball, which is a period of time in the universe when the temperature was, say 10 billion degrees, and before that, we have to extrapolate. We don't have really direct observations. And then there's the Big Bang singularity. And I think we have to distinguish between all three of these things. Inflation, I think, really severs the link between the Big Bang singularity.
What's that?
That's the sort of, when quantum mechanics and gravity both you need both to understand both of them at the same time. You need the quantum gravity theory that he was talking about, where sort of all physical quantities that we can talk about now go to infinity or zero. So it's kind of an end of space-time. And that's sort of the popular conception of the Big Bang. But I think inflation severs the link between that singularity and the Big Bang fireball. There could be a singularity and then lots of inflation and then the Big Bang fireball. So I think that the transition from inflation to the fireball, we don't know exactly how that happened, but it's not very speculative physics. That's particle physics we don't know.
Well, let's get another question, too. Maybe you guys can talk about it further afterwards. There was another question back here, yeah.
Thank you. Bringing it a little closer to Mother Earth, there are those who say that we know more about external to the Earth than we do about our oceans. And UCSC is very big in oceanographic studies. And yet, if you look at it from ways to better man's lives, there's always a limited amount of resources in how you allocate them. And many people believe that by studying internally instead of externally, there would be more of a benefit to humanity. How do you defend, if indeed you need to defend, the vast amounts of money that are, you probably don't think it's large enough, of course, but how would you defend maintaining or increasing your slice of the pie compared to the more esoteric Earth studies?
Yeah, so here's where the $5,000 comes in. That's sort of the sort of numbers we're talking about in this sort of research. So first, I think to consider cosmology research and sort of ocean physics and ocean science research as a zero-sum game, we really should not think of it that way. There are so many items in the federal and other budgets that are so many orders of magnitude bigger that we should all, anyone interested in science in general should be working to get more money into science in general and certainly not trying to get money out of ocean sciences or vice versa. So,
Limited amount of resources and constant fighting.
But it's like arguing over the change in the couch when you're spending hundreds of thousands of dollars a year on other things. So it's just not worth arguing about. The argument is about whether it's worthwhile compared to building, nuclear missiles or something like that. So I just don't think that's how to allocate across divisions, say in the National Science Foundation is the target to go for. It's how do we get more of the budget into the National Science Foundation. So, I think there are legitimate questions about, should we be spending valuable money? I guess it's $5,000 is valuable. Should we be spending that money on doing something that doesn't seem to have any practical use? And I'm the first to admit, I'm happy to tell people, what I do most of the time is completely useless. It has no practical use, I think. You're not going to get a better toaster out of understanding the origin of galaxies. But I think there are a lot of things in the world that don't have a practical use that are totally worth doing. I think we create stuff and we live partly so that we can enjoy all of those things. And to me, understanding the universe and our place in it is one of those things that's totally worthwhile, even if it, doesn't make better cheese whiz. So.
And that's where you have friends in the humanities too.
Yes, it's exactly the same argument, I think.
But what if you could cure cancer or something like that?
That would be great. What do you want me to say? But I don't think you're going to cure cancer by taking money away from cosmology or, for that matter,
literature
from
history.
From history or literature.
That's right. Here. We have a question on this side. A couple of questions.
Before quantum mechanics and the general theory of relativity, Rayleigh said there was two dark clouds on the horizon that needed to be resolved. So are dark energy and dark matter the clouds on the horizon now?
Dark energy, probably. So this, he was very prescient, right? Because he pointed to exactly the right two experiments.
Could you explain what?
Yeah, so he pointed to the Michelson-Morley experiment, which was kind of at odds with the current understanding, and correct understanding came from Einstein's theory of relativity, and then the photoelectric effect and the correct understanding of that sort of led to quantum mechanics. So the two major 20th century sciences in physics came from these very two experiments that he was like, well, wait a minute, what about these? So yeah, I wish he was around now to tell us what to pay attention to. But my personal suspicion is that dark matter is going to turn out to be, one of the many theories that's been devised, and it will be super interesting and exciting to figure out what it is, but it won't fundamentally change our conception of physics. I think the dark energy is enough of a mystery that sort of all of the solutions to it, all of the explanations are pretty weird and really kind of revolutionize things. So if I could get some super intelligent being to tell me the answer to dark energy or dark matter, I would totally pick dark energy in a second. I think that.
What is dark energy? You're pretty intelligent.
Sorry.
Can you fill us in a little bit about what?
So dark matter is
Yeah.
stuff that gravitates and it holds together the galaxies. About 30% of the universe is made of dark matter, roughly. 5% or so is stuff like us, protons and neutrons and so on. And the other 70% is, 20 is more like 25, 5, and 70% is the dark energy. So it's kind of major components of the universe. But dark energy isn't like normal matter. It doesn't gravitate, it anti-gravitates, it doesn't cluster, it doesn't seem to interact with things in any normal way. We know that it's there from its effects, but we have no idea what it is.
Okay.
And all of the explanations are bad.
Don't have the physics yet. Okay.
Why?
Over here. Yes.
Going off of the point of like science and civilization as being separable or inseparable concepts, I'm finding it difficult to imagine them as being separable because when we think of science, like for example, when we started the conversation, we're talking about the origins of the word cosmos and the cultural significance between this Western and this Chinese, background. And like when we're referring to things, we have to refer to them, as both the scientific concept and the ownership of the person or the things that created it. And moving forward and going into modern science, thinking of ideas as being, separable from the people that created them. Can you maybe elaborate on how we're drawing such cultural significance from, naming these things that, we have history and it drives our motivations for, looking at questions in the future.
Sure. Yeah, of course you can, especially for historians, we view things in context. Things, of course, happened in a specific place and in a specific time. But things also move around. Think about translation. Think about technological transfer. Think about how things move from China to Santa Cruz. Think about how we can communicate. Think about the concept we use. Those things move across not only cultural borders, but also civilizational borders. Okay, things might change a little bit, but things do move around. Okay, and I can tell you that the most passionate believers, the most passionate believer that science is universal today is Chinese elites. They firmly believe that science is universal. That's how they can catch up.
Yes, please.
Okay, so given that I would suggest that our intense focus on the beginning of the universe does in part derive from the sort of Christian perception of the creation of the universe and having a very specific beginning point. So not to say that it is or isn't true, but I think that we've had that assumption for some amount of time. But my question really is, given that China is clearly catching up, and that traditional Chinese medicine continues to be embedded in the Chinese understanding of the world, how might that affect our perception of the cosmos in the future? Any thoughts?
I do have some. Well, most Chinese elites today are fairly westernized. But think about Chinese populations, 1.4 billion now. 50% of them are peasants, are farmers. Okay, so how many are there? One. There are a lot of farmers, right? They still pretty much possess that sort of cosmology. Their parents and grandparents, their grand-grandparents have been. The Cultural Revolution did not wipe that out. The interesting part is that they still, and I talked to some of them before, and then I found out that that kind of traditional cosmology survived in peasant society somehow. Okay, and we are talking about highly educated, westernized Chinese elites that they believe in science. And what kind of cosmology they might have in the future with this kind of Chinese medicine going on, and most urban dwellers, most people in Shanghai or Beijing, you go and you find out they believe in both. They would try, Chinese medicine, see if it works. If it does not work, oh yeah, and they have all kind of theory about it, and then they'll go to a modern contemporary hospital and try it out. And if they tell you, you have a cancer, you cannot survive in 6 months, they will go to a Chinese doctor and then get more therapy and consultation and all that. They believe in both, and I found that very interesting.
Yes.
Thanks. It's been really interesting to hear your conversation. Thinking about the interdisciplinarity of the talk tonight, I'm wondering if it's true that we're expansionist and one of our two options is to colonize the planet, the universe. What can we learn about the clash of civilizations between the West and the East, in the case that we've been hearing about on this side, and also about the history of colonization on our own planet and the harms that it's caused? What can we bring out into the universe, and how can we do that in an ethical way?
You mean, can we learn from the history of colonization here?
Right, and how do we proceed with this expansionism, but also learning from the humanities and our human history?
That's a great point. It might not be for a while when it becomes practically relevant, but I personally think that would be a really important thing to do, is to look at the history of these kinds of exchanges and interactions on our planet, if we ever do make it beyond into other galaxies, or and I hope that there is some kind of team of historians and philosophers and literary scholars, along with scientists anthropologists and so on, who would look at what's happened here when we do that.
Mm-hmm.
Okay, we have time for a couple more questions. Yeah, Ty. Ty's going to ask me questions.
So I wanted to ask about the relationship between cosmos and time. Usually there's some sort of accompanying notion of time with the cosmos. So I would be interested, Minghui, if you could just say a little bit about how they conceive time. You suggested this idea of neither beginning nor ending, which is it's a particular notion of time. And for Anthony, I wanted to just ask a very specific version of this question, which is, I think I understand time from within the universe that's formed from the Big Bang. And I'm just wondering if time in this inflationary period is the same thing that we're talking about after that.
Yeah, so, well, I can just, in terms of that technical question, pretty much in the sense that inflation, if it happened, was still a phase where the same Einstein's theory of general relativity still held. There's still the same space-time structure and so on. One thing that's a bit different is that in the observed universe, time has a very specified direction, right? Things don't unhappen. The inflationary phase has that same arrow, but it's subdued in the sense that if you're just in the middle of this inflationary epoch, you can't really tell which direction time is going. There are sort of secret processes that will reveal that, but it is more of a sort of timeless realm, I would say, than the one we inhabit. Do you want to?
You probably all heard of a Chinese New Year, and it's coming up, right? And it's in different day each year. It's calculated based on a lunar solar calendar. And that calendar is so exotic to us, we cannot possibly imagine that, because they didn't even use the very unit, like hour, like weeks that we use. When European missionaries first arrived in China, the first, most urgent task for them to do is to figure out which day is Sunday.
You know what? That's a great place to end. So luckily, we have this space until 9 o'clock, and you are welcome to hang out, to drink more, and to talk with our resident experts, whom I want to thank once again, and to all of you, thank you.